Assalamualaikum. This is our group presentation about fuel gas, natural and petroleum gas. This is our team members. Muhammad Amyrul bin Muhammad Anuar, Muhammad Nasrullah bin Muhammad Nazman, Muhammad Syaifullah bin Ramli, Muhammad Asraf bin Abdullah, and Muhammad Haikal bin Muhammad Shukor.
History. Petroleum has been used since ancient time. The first recorded discoveries of petroleum were when builders in ancient Babylon found petroleum deposits on seashores and found that it was flammable. Since then, petroleum has been used for energy in light source, cooking food, and heating in different forms. Natural gas has not been used for as long of period of time because it is extra difficult to extract from the earth. Natural gas is now more common than petroleum for household application and especially foreign vehicle. Introduction. Fuel is simply a combustible substance. Natural gas was formed millions of years ago from decaying vegetable matter generally, along with petroleum. Petroleum gas is a mixture of gases that is produced as a byproduct of petroleum refining. It is composed primarily of propane and butane, but it also contains small amounts of other gases, such as ethane and pentane. Petroleum gas is a flammable gas that is often used as a fuel for cooking, heating, and vehicle.
Advantage and disadvantages. Natural gas. Advantage for natural gas: cleaning burner fuel that produce fewer pollutant than coal or oil. Absolute and release source of energy. Relative inexpensive fuel can be used to generate electric, heat homes and business and power vehicle. Disadvantage: can be explosive if not handled properly. Can be odorless, make it difficult to detect leak. Can contribute to climate change. Other to produce fewer emission than coal or oil. Petroleum gas. Advantages: flammable gas that is often used as a fuel for cook, heating and vehicle. Relatively expensive fuel. Can be stored in liquid form. Make it easy to transport. The advantages: can be explored if not handled properly. Can be odorless, make it difficult to detect leak, or produce more emission that natural gas contribute to climate change.
Discussion and calculation. Description. Fuel oil is a petroleum-based liquid fuel that is commonly used in various applications, including power generation, heating, and industrial process. It is a viscous and heavy liquid that can vary in composition, with different grades available for specific purpose. Fuel oil is typically classified into several categories, including residual fuel oil (RFO). This type of fuel oil is the heaviest and most viscous, with a high sulfur content. It is commonly used in industrial boilers and power plants that are equipped with pollution control equipment to manage emissions. Distillate fuel oil (DFO) Distilled fuel oil is lighter and less viscous than residual fuel oil. It includes diesel fuel and is commonly used in diesel engines for transportation and backup power generators. Example: in a power plant, a common example of the use of fuel oil is in a system turbine power generation system. Residual fuel oil (RFO) is often used in a boiler to produce steam. The steam is then used to drive a steam turbine, which generates electricity. This setup is prevalent in many power plants, especially in areas where natural gas availability is limited. Solution for fuel oil use. One solution to mitigate the environmental impact of using fuel oil, especially the high sulfur residual fuel oil, is the installation of flue gas desulfurization (FGD) system in power plant. FGD system remove sulfur dioxide (SO2) emission from the fuel gases, reducing air pollution and minimizing the environmental impact of burning fuel oil. Reference: Thermodynamic and Engineering Approach by Yunus A. Chengel and Michel A. Boyce. Natural gases.
Calculation for the power output and efficiency of a simplified natural gas-fired power plant and petroleum-based power plant. Natural gas-fired power plant assumption: natural gas lower heating value LHV 50,000 kJ per kilogram. Gas turbine efficiency 35%, steam turbine efficiency 40%. Overall plant efficiency 35% times 40% equal to 14%. For the input, mass flow rate of natural gas m dot gas is equal to 1000 kg per hour or 1 ton per hour. For sample calculation, energy input or Q in equal to m dot gas times LHB. Q in equal to 1000 kg hour times 50 kJ per kilogram equal to 50,000 kilojoule per hour. Power output Q in time overall plant efficiency. The power output is equal to 7,007 megawatt. Another sample calculation for the power output and efficiency of a simplified natural gas-fired power plant and a petroleum-based power plant. Petroleum-based power plant. For the assumption, petroleum fuel lower heating value LHV equal to 45,000 kJ per kilogram. Diesel generator efficiency 40%. Input mass flow rate petroleum fuel m dot fuel equal to 800 kg per hour. For the calculation, energy input Q in equal to m dot fuel times LHV. The value of Q in after the calculation is 36 million kilojoule per hour. For the power output is equal to Q in times diesel generator efficiency. After calculation, the power output is 14.4 megawatt. So, in this simplified example, the natural gas-fired power plant has a power output of 7 megawatt, while the petroleum-based power plant has a power output of 14.4 megawatt. This calculation illustrates the power generation capacity of these two types of power plant based on their fuel input and assumed efficiencies.
Summary. Overall, natural gas is a cleaner burning fuel than petroleum gas, but it is also more expensive. Petroleum gas is a more versatile fuel, but it is also more dangerous. The best fuel to use depends on the specific application and the environmental regulation in place. Natural gas and petroleum gas are clean burning, reliable and efficient fuel that can be used to generate electricity in power plant. However, they are non-renewable resource and can contribute to climate change. It is important to note that the use of natural gas and petroleum gas in power plant is controversial.